Good day, guys. We want to look at center of gravity again. So we have seen this graph before. So when we're doing it the first time, I said it can be solved in two ways. I solved it first of all with a vertical strip. Now I want to show you how to handle the same thing in case you choose to go for a horizontal strip. So we want to sketch the graph of y equal to the square root of 9 minus x squared, which is a semicircle. Show the strip that we use to calculate the volume generated when the area bounded by the graph and the x-axis rotates about the y-axis. Then we'll calculate the volume and the distance of center of gravity from the x-axis. So I've picked out the important information I need: the name of the graph, the equation of the graph, that is it. The x-axis was mentioned, which is y equal to 0. Then x-axis, y-axis rotation. This one is very important because it tells me how my formula starts. So we all know that a semicircle comes from a full circle where you make y the subject with a positive sign. That's the upper half of the circle. So those are the things that my N6 students are supposed to be used to. So I'm trying to sketch the upper half of my circle. So it looks like that. Let me centralize the y-axis. So that is my y-axis. This is my x. So you see, if you square both sides, it tells you that it's coming from a circle. So that makes you to see that the radius is 3. So this is 3, negative 3, and that is positive 3. So they said we need to show the regions bounded by the graph and the x-axis. So that is the graph and the x-axis. So we're showing everything there. They didn't restrict us to first quadrant or second quadrant, so we're doing everything. So we have solved this problem before with a vertical strip. So let's see how we can do it with a horizontal strip. So the key thing here is to understand that when you are putting a strip within a shaded portion, it should not touch the same graph. So I can't take my strip from here to there. That is not allowed because I'll be touching the same graph. So either I put it in the first quadrant or I put it in the second quadrant. So I can choose anyone to avoid working with negative numbers. Let me put it in the first quadrant. So that is what I will do. So once I put it in the first quadrant, I know that since it's y-axis rotation, when it rotates, it covers that portion. So it shows to me that my strip touches the y-axis. And once it touches the y-axis, it immediately tells me how to label my graphs. I label my graphs using x with x1 on the right side of the graph. So if I want x1, I'll go back to this equation. Square it comes like this, then I take x as the subject. So I'll get the square root of 9 minus y squared. Then my x2 is on the left side of the graph. So my x2 is equal to 0. So I guess that is my graph. I've put my strip inside, and now it also shows that since my strip is touching the y-axis, all my formulas must end with y, and my limit now break along the y-axis. So that's our story. So we are done with sketching the graph, shading the portion between the graph and the x-axis, putting our strip there. Now it's time to get the volume. To get the volume, the rotation, you see, it's very, very important. The rotation tells you how your formula starts. So my formula will start with Vy, then my strip tells me how my formula ends. You see your strip touches the y-axis, so your formula ends with dy. Then the job of an N6 student is to go to page 5 of your formula sheet, search for the formula that starts with Vy, ends with dy. So that's your formula. You get x1 squared minus x2 squared dy. So that's how your formula looks like. And this time it's the disk method because you see your strip is perpendicular to the axis of rotation. The shell method, they are parallel to one another. So I will now bring my limit along the y-axis. You see, because the strip says so, it touches the y. So my limit will be from 0 to 3. Then I take x1 and square it. That will give me 9 minus y squared. My x2, luckily it's a 0. So this is a simple thing I'm integrating. So if I integrate this, I'll get 9y minus y cubed over 3 from 0 to 3. Then I put my limit. The upper limit is a 9. 9 times 3 over 27. get 0 minus 0. Then you see that 27 minus 9 gives us 18 per unit. So for those who follow the other video where I solved this problem with a vertical strip, you remember that our answer was 18 per unit with a certain 56 comma whatsoever. So that's how simple your volume is. So we can now go to the C part, which says calculate the distance of the center of gravity from the x-axis. So distance of center of gravity from x-axis, that is the definition of the y-ordinate of the center of gravity, the distance of center of gravity from the x-axis. On page 5 of the N6 formula sheet, that is defined as the volume moment about x over the volume, where the volume moment about x, it's also defined on page 5 of the N6 formula sheet as the integral from a to b r dv. So we need to develop this again using our diagram. So dv is always the formula I've just used to calculate my volume. So that will be my dv. So I'm recopying that formula starting from outside, the integral from a to b. I will leave space for r. I'll get my x1 squared minus x2 squared. That's my formula for the volume. Then to get my r, I must go back to my graph. I start from the center of my strip. I move in a straight line to the x-axis. So I'm going to my graph to do that practically. So to get my r is the distance that starts from the center of my strip to the axis that is written there. The axis there is the x-axis. So if I move down, you see I'm going to the x-axis, and that is the vertical movement. So once I get a vertical movement, I describe it using y, since it is in line with the y-axis. So my r is a simple y there. So I can now do my substitution like I did this side, a and b as 0 to 3, y into x1 squared minus x2 squared, we did it already. We got a negative 9 minus y squared dy. Then I'm opening my bracket to get 9y minus y cubed dy. Then I integrate, I will get 9y squared over 2 minus y to the power 4 from 0 to 3. Then I substitute my limit. The upper limit, you are a 3. Sorry, I need to write my pi outside first. So I have pi, the upper limit is a 3. I put 3 there, 3 squared is 9, 9 times 9 is 81 over 2. If I put 3 to the power 4, it's another 81 over 4, which is something we've done already. We see that 81 over 2 minus 81 over 4 give us 81 over 4 pi unit to the power 4. So that's the area and volume moment about the x-axis, and therefore y bar, as you can see from the definition, it's volume moment about y, 81 over 4 pi, divided by volume. Volume was 18 pi. Once we do that division, we should be able to get ourselves to the center, the y-ordinate of the center of gravity, or the distance of center of gravity from the x-axis. So I'm taking 81 on 4, I divide by 18, 6 pi will cancel itself, that will give me 9 over 8, 9 over 8 unit, or if you prefer this mouse, you will get 1,125 unit. So that is how I calculate the distance of the center of gravity from the x-axis, which is the y-ordinate of center of gravity. So I've shown how to do that with the horizontal strip I did earlier with the vertical strip, and you can see the difference that the shaded A portion is flexible and can take any strip. One method will always be easier than the other, and it looks like this one of horizontal strip works faster for us. But the key thing is that if you come to volumes where you read your limit, must be where you put your strip. So you see I'm reading my limit from 0 to 3 because my strip touches the y-axis, so it tells me so. So guys, that's how simple it is to calculate our center of gravity. Thank you very much.